This is a follow-up video to the first video this morning regarding the battery balancer and the battery BMS issue. Originally this morning when I powered up the system, I was trying to apply power to the house with the inverter, and the inverter kept cycling on, and then once it tried to carry the load, it would kick off again. Originally, I wasn't sure what was going on, and I found that the battery number 4 BMS, the output FETs were actually toggled off. You can turn off and on the output and the charge FETs with the HumSync BMS. Battery 4's FETs were turned off for the output, but the inverter was still turning on, and everything seemed like it was normal until it tried to carry a load. When I noticed that battery 4's voltage was showing low on the battery balancer, I did some testing with my fluke meter and confirmed that the output voltage in that battery was low, and that's when I noticed the FETs were turned off. I was curious why my inverter was still turning on fine and would run with no load or a very low load, less than 2 amps DC from the battery bank. It would carry, the lights in my garage. Well, I realized what was happening. I took some more tests this morning and realized that because I have this battery balancer installed on my battery pack, with the output FETs turned off in battery number 4, the battery balancer was seeing that the voltage was low on that battery, and it was shunting power from battery 1, 2, and 3 over to battery number 4 to bring up its voltage. When I turned on my inverter, I first charged the capacitors in the inverter with just a light and a wire to bypass the switch I have. So I charged up the capacitors, and then I was able to turn on the inverter, and it idled fine at about 45, 50, 48 watts, and it was able to power my overhead garage lights, but any other load bigger than that, it would shut down. And that's because the only power that was being added to the battery bank to replace battery number 4 was coming from that battery balancer. So just battery 1, 2, and 3 were adding up to 36 volts basically, and then battery 4's voltage with the output FETs turned off was entirely coming from that battery balancer. It was outputting a few amps to the wires going to battery 4. That was enough to actually charge the capacitors and turn on the inverter and idle, and actually even power my overhead garage lights. Once I turned on the output FETs for battery number 4, it worked fine. But just to let you know, if you turn off the output FETs, or if your BMS turns off its output FETs on one of these batteries, the other 3 batteries and the battery balancer are going to try to feed power to that battery. And the input FETs were still turned on actually in that battery. And so that battery balancer was feeding more power into battery number 4. And when I turned on the FETs, I noticed that battery 4, actually its individual cells were showing at a much higher voltage than the cells in battery 1, 2, and 3, and they should have been equally charged, but now it actually is slightly higher in charge when you look at the individual cell voltages. So I could see that that may be a problem, having one of these battery balancers hooked up on here 24 hours a day, 7 days a week. If you turn off your output FETs, that balancer is not going to see voltage from that battery now and try to shunt power from the other batteries. You could potentially overcharge one of your batteries, where the only thing that's going to stop that from happening is the internal BMS. You're going to hit your high cell individual cell voltage disconnect for that battery. So I think everybody needs to be careful about using these battery balancers on a full-time basis if one of your batteries, the output FETs do get turned off in one, because that potentially could be a problem. The only level of safety you're going to have for preventing your cells from overvoltage is that BMS then for the individual cell. And I haven't done any more testing to see if it actually will make sure and shut that off either. So, but that was the issue I was having this morning with the output FETs turned off. The balancer was still feeding power through the wires that are connected up to battery 4, and that's why my inverter still turned on. Once I disconnect that battery balancer and turn off the output FETs for one of my batteries, then the inverter won't turn on. There's no power there because that one battery's turned off. So these battery balancers will provide enough current to turn on your inverter even if that battery, one of those batteries, are turned off. All right, have a good day.